Hi there, I'm Matt Keene. Welcome to Creating a Future We Want, the Visionary Evaluation Series, where I make a little video about every single page of... Hold on! Not the right book! This is a book by Brian Greene, The Fabric of the Cosmos. Elegant Universe is another great one. But I don't write books about grand tours of the universe. So, what is this doing in my hand? I was meaning to talk about page 12 of Visionary Evaluation, the Visionary Evaluative Principle number 2, which is recognize the world as composed of living entangled systems. What am I going to do now? What a kerfuffle we've gotten ourselves into here. So, let's see what happens. This should be interesting. So, that too, world as composed of living entangled systems, it reminds me of some of my very tiny little bit of understanding of physics and what's going on in that area of research, science, understanding of nature and the universe. Every age develops its stories or metaphors for how the universe was conceived and structured. Isaac Newton, he introduced the notion of it being like an enormous grand clockwork, deterministic, mechanistic. After it was all wound up and set into its initial state, the clockwork universe ticks from one moment to the next with complete regularity and predictability. Now, Einstein's works with special and general relativity threw a wrench into that clockwork in some aspects, space, different conceptualizations of space and time and relationships therein. However, they agree, if you know where every particle is and how fast and in what direction each is moving, you can, in principle, use the laws of physics to predict everything about the universe into the future and into the past. Quantum mechanics, now this says, no way. You can't ever know the exact location of and the exact velocity of even a single particle. We can't predict with total certainty the outcome of even the simplest experiments. Quantum mechanics shows that the best we can ever do is predict the probability that an experiment will turn out this way or that. Ooh, interesting. Clock metaphor, no worky. There's another concept that I was reminded of, which conveniently is mentioned on the next page, locality. Now, this is kind of the assumption in physics, age-old assumption, let's say, that in order for one thing to cause a change in another thing, a direct change in the other thing, they have to be next to each other. There has to be something that goes between this thing and that thing for this thing to cause a change in that thing. Locality. Also, quantum mechanics causing some problems here. It's shown that something we do over here, such as measuring certain properties of a particle, can be subtly entwined with something that happens over there, such as the outcome of measuring certain properties of another distant particle, but nothing was sent from here to there. Nothing. Einstein thought this was spooky. Totally spooky. If he thinks something's spooky, I'm thinking I should think it's spooky. Basically, quantum mechanics says that space can't be thought of in the way that it once was. Intervening space between, no matter how much there is of it between two objects, quantum mechanics allows for this notion of entanglement, a kind of connection between two things, no matter how distant they are. Okay, a few things come to mind here. This locality assumption, built into everything that we understand about physics and our assumptions about how the world works, was this idea that in order for there to be a relationship between one thing and another thing, where this one thing causes a change here, they have to be next to each other. Okay, interesting. All right. Also, this notion of connectedness and entanglement that quantum mechanics introduces to the whole thing. Holy crud. So this is like this ubiquity of connectedness in the universe. Okay, that's not how I grew up thinking about everything. Also, the idea that physics, one of the oldest disciplines to exist, where we've had the longest history of research and investigation into all sorts of things, is racked with uncertainty, unpredictability. These two areas of Newtonian and quantum haven't been reconciled. I don't know how they work together. There's not a clear understanding of the relationships there. We don't know, physics, one of the oldest fields, disciplines to exist, does not understand where some 96% of the mass in the universe is. That seems like a problem. But the amazing thing is, right, that it's not that that field and the people working in it and the discipline, that domain, does not know these things. It's that they continue to investigate in spite of these massive gaps in understanding of what's going on. Not trying to artificially control or ignore a bunch of stuff just because they don't understand it. Okay, visionary evaluation principle 2. Visionary evaluatives recognize that every issue is part of entangled living systems. Ew, my goodness. They recognize that the systems are plentiful, nuanced, networked, messy, beautiful, and most especially living. Visionary evaluatives move from looking at a particular issue in linear, isolated, and static ways, clocks, towards seeing that the issue in larger, interdependent, and constantly shifting and evolving systems, the systems in which it exists. Visionary evaluatives also know that an evolving issue often forms discernible patterns within an entangled living system. Issues emerge and may mature, thrive, flourish, be threatened, rebalance, adapt, evolve, die, and or re-emerge. The goal is not to sustain the intervention, organization, and or system, but to allow for the transformation of the social ecological patterns toward more sustainable, equitable future. So, what would be a metaphor for the universe today that accounts for human values? I'm Matt Keene. Thank you for visiting Creating a Future We Want, the Visionary Evaluation Series. What would be your vision of a comfort with our ignorance and our uncertainty? And going forward anyway.